All right, welcome back. So last class we spent a lot of time talking about the vertex form of a quadratic function, which just as a quick recap looks a bit like this, where we have a times x minus h squared plus k, and our vertex is the point hk. So in our vertex form, it's really easy for us to find, well, the vertex. But the standard form of the quadratic function is the one that you tend to see the most, and that looks something like this. That looks like ax squared plus bx plus c, where a, b, and c are all real numbers, and a does not equal 0. So this tends to be the form that we see things in, and for those of you that remember doing the quadratic formula back in Algebra 1, this particular form is the one that we use to do the quadratic formula, because we can plug in a, b, and c directly from our standard form into the quadratic formula. Now, sometimes dealing with our standard form is actually the easiest way to deal with a particular equation, depending upon what it is we're trying to use it for. And so we do need to know how to convert from vertex form into standard form. So to do that, the first thing that we're going to need to deal with is with expanding this binomial here in the middle that's being squared. So just as a quick reminder on how to do that, if we have negative x minus 3 squared, that's really the same thing as x minus 3 times x minus 3. And there's a couple of different ways that you've been taught how to do this. The first method is probably the FOIL method, but the method that I personally prefer is the box method. So that's going to be what we do on this particular video. For the box method, you set up a box. You put your first binomial on the top. You put your second binomial on the bottom, and then you multiply going sort of top to bottom. So x times x gives me x squared. X times negative 3 gives me negative 3x. X times negative 3 gives me negative 3x. And negative 3 times negative 3 gives me positive 9. And then I can rewrite my new expression here. This guy and this guy don't have any like terms for me to combine with, but these two things will combine. And so the product, when I go and multiply these two things together, is x squared minus 6x, because that's what negative 3x plus negative 3x is, plus 9. So we've simplified that part, but we still have to deal with the rest of it. So now I am left with this. Instead of our x minus 3 squared, I now in the parentheses have x squared minus 6x plus 9, and that plus 5 is still hanging out. So I'll go through, I'll distribute the 2 to each of these terms. I'll end up with 2x squared minus 12x plus 18 plus 5. And then I can finally combine those two constant terms at the end, and I'll have 2x squared minus 12x plus 23. So this is equivalent to what I started with. It's just in a different form. So instead of being in vertex form, now I'm in standard form. Now, one of the nice things about graphing in standard form is that it lends itself, like I said before, really easily into doing things like the quadratic formula or into factoring. We tend to be able to find our x-intercepts pretty easily when a quadratic function is in standard form. We can also find our y-intercept really easily, but what we can't find easily is our vertex. So the way that we find our vertex in standard form is we have to use this particular formula here, negative b over 2a. And if this looks familiar, it definitely should. It's part, but not the whole thing, part of your quadratic formula. So negative b over 2a will give us the x value of our vertex, and then we'll plug it back in to get our y value. So how on earth do I use that? Well, to do that, I need to know what my a, my b, and my c values are in this particular standard form of the equation. So my a value is going to be the coefficient that's in front of my x squared, and you'll notice there's nothing there, so that means that my a value is 1. My b value will be the coefficient in front of my x term, so that's -6, and my c value will be my constant that's at the end, which is -1. Now I'm going to plug this information into this little formula right there. So -b over 2a. So I have -6. My 6 was already negative, so I'm going to leave that alone. 2 times my a value, which is 1. These two negatives are going to cancel out. I'm going to end up with 6 over 2, which is going to give me an x value of 3. Now I have to figure out my y value, so I'm going to plug 3 in to my original quadratic function up here. So 3 squared minus 6 times 3 minus 1. I'll have 9 minus 18 minus 1, which will give me, let's see, -9 minus 1 more is -10. So my vertex is going to occur at 3, -10. So I can plot that pretty easily. Now, the great part about knowing my vertex is it gives me a couple of pieces of information. First, if my vertex is here, I know that there's that really wonderful invisible line, the axis of symmetry, going right through it, right here. That's our vertical line that splits our parabola in half and allows us to reflect any points on one side over the other. So my axis of symmetry here is occurring at x is equal to 3, that vertical line. Also, because I know where my vertex is, I have a starting point that lets me figure out other points pretty quickly. So let's erase some stuff, give ourselves a little bit more room here. I'm going to leave my vertex and my function, and then I'm going to set up a little table here so that I have a place to put some of my points. So x, y, and I'm going to put the point 3, -10 kind of right here in the middle because I know that that's going to be my vertex that's in the middle of my parabola. So when I go to choose points, I'm going to pick things on either side of 3. I'm going to count down, and I'll count up as well. So 3, 4, 5, and 6. So first, let's plug in 2. So I'll have 2 squared minus 6 times 2 minus 1. I'll have 4 minus 12 minus 1, which is going to give me -9. So that means 2, -9 is a point, which is right here. Now, again, because our axis of symmetry is going through our vertex, if 2, -9 is a point, then the exact same point is occurring on the other side of my vertex, which means that 4, -9 is a point. So I don't have to do out all the math for that. I can just reflect the point over. Let's do 1 next. So if I plug in 1, I have 1 squared minus 6 times 1 minus 1. So I have 1 minus 6 minus 1, which is going to give me, let's see, 1 minus 6 is -5. -5 minus 1 is -6. So I'll end up with -6. And again, if I have -6 there, I'm going to have -6 here. So 1 -6 is going to be, let's see, 1, 2, 3, 4, 5, 6, going to be right there. And the exact same point is going to be reflected on the other side. So we can start to see my parabola is taking shape. Let's do one more thing. Let's plug in 0. Now the great part about plugging in 0 is that's going to give us our y-intercept. And it means that most of what we have in our function is going to cancel out. And we're just going to be left with -1. because if I make x squared 0, then it's still 0. 6 times 0 is 0, so I'm just left with negative 1. And once again, I can reflect that over on the other side, and then I'll have a very nice picture of what my parabola looks like. Here's one for you to try. Take a moment, start by seeing if you can figure out the vertex. That's your first step. So quick reminder, your vertex, the little formula you need to figure out your x-coordinate of your vertex is negative b over 2a. Pause the video, see if you can figure out both the x and then the y-coordinate of your vertex. All right, so your b value here is 8. So I'm going to plug that in first. I have negative 8 over 2 times negative 2. Now, yes, the 8 in my quadratic function is positive. My function my formula contains a negative, so I get to add that in. So I'm going to have negative 8 over negative 4, which is going to give me a value of positive 2 as my x-coordinate. Next, I get to plug that back into my function. Specifically, I'm looking to see where is g2. So I'm going to plug that in. Negative 2 times 2 squared plus 8 times 2 minus 10. I'll deal with my exponent first. So I have negative 2 times 4 plus 16 minus 10. This becomes negative 8 plus 16 minus 10. And that's going to give me a final value of negative 2. So my vertex is going to be at 2, negative 2. So 2, negative 2 is right here. 2, negative 2. And again, that gives me a nice little starting point for figuring out other points on this parabola. So give myself some space here. I know that I'm working on the other side of positive 2, so on either side, rather, of positive 2. X, Y, I'll put positive 2 right here in the middle. We're going to take a look at 1. We're going to take a look at 0. We'll take a look at 3 and 4 and see kind of where that gets us. So again, we know that 2 gave us negative 2. Let's see what happens if we plug in 1. So if I plug in 1, I have negative 2 times 1 squared plus 8 times 1 minus 10. This will become negative 2 times 1 plus 8 minus 10. So I'll have negative 2 minus 2, which is going to give me negative 4. And that also means, because of my axis of symmetry that's going right through my vertex, that if I have a point at 1, negative 4, I'm going to have one at 3, negative 4, because it's going to be mirrored on the other side. And the first thing I'm actually noticing with this is my parabola is facing down. It is going away from the x-axis, which makes a lot of sense, right? We have that negative in front, and we know that if we have a negative a value that is reflecting us across the x-axis, our entire function is going to be facing in the opposite direction. So that checks out. Let's plug in 0. If I plug in 0, everything cancels out except for that negative 10 right at the tail end. And same thing on the other side. So that will be here and here, and my parabola will look just like that. Try putting it all together with some of the other stuff we've talked about. So take a moment, pause the video, find the vertex, find the y-intercept, graph this, and then decide when is this particular function increasing and when is it decreasing. So starting off with finding our vertex, that's going to be negative b over 2a. So this is going to be negative negative 6 over 2 times a, which is 1. So this is going to be 6 over 2, which is 3. So my x-coordinate's at 3. And for my y-coordinate, I'm going to do, let's see, 3 squared minus 6 times 3 plus 1. So this is going to be 9 minus 18 plus 1, which is negative 9. This is going to be negative 8. So my vertex is going to be at 3, negative 8, which I will start by plotting here. So 3, negative 8. The next thing I'm asked for here is my y-intercept, and even if I just get my y-intercept, I'll have enough points to at least generally get a picture of what this looks like, right? Because if I have my y-intercept, then I know at least one other point on the other side. I get my y-intercept by plugging in 0. So if I plug in 0, I end up with positive 1 as my y value, which is going to be here. And I'm noticing that's 3 away from my axis of symmetry, so 3 on the other side is here, which means that my parabola is going to look something like this. Not being super exact here, but you get the idea. In terms of increasing versus decreasing, I am noticing that as I'm approaching from the left, my function appears to be decreasing. It is going down until I get to my vertex, and then it begins to increase on the other side of my vertex, and it increases off the graph. So for my increasing value, I am increasing from 3, which is the x value of my vertex, to positive infinity, because this increase is going to go on forever. But before that 3, I'm decreasing. So that's going to be from negative infinity to positive 3.